Hi, I'm Jeffrey Lessel. You can call me Geo. And today we're going to hack on some Emacs Lisp. And specifically, I would like to try to get my head around using the URL package that's built into Emacs in the later versions to eventually retrieve a list of PRs that are open for a repository on GitHub. So it's going to be interesting, I think. Hopefully we'll get pretty far. We'll see how far we can get. So let me show you what we've got going here. I have in my in this little scratch buffer here just kind of some things I'd like to do before we are done with this feature. I would like to be able to, by the end of the development cycle, I would like to be able to see a list of PRs that are open for a particular repo and have a chooser that I can use to then open up that PR in a browser. So these are kind of the steps that I think we're gonna have to go through. If you watched my last video, you saw me start to try to get into the URL library, and that didn't work so well. Let me turn my camera on there. And hopefully we can get a little further this time on that. I did a little bit of research, but we're still going to try to struggle through this together. And then next we're going to get specific values from the URL response, specifically a JSON response, so we can try to figure out how to grab JSON values, like a key value pair, out of some JSON from a response. Then we're going to dive into using authinfo, which stores usernames and passwords, and you can encrypt that. And honestly, instead of doing a live stream like I have done on the past few, this one I'm going to record beforehand because there is authorization information. I'm using my real GitHub credentials to log into GitHub here. And I want to make sure not to leak those. So I'm doing this as a video to edit, to be able to edit instead of just doing it live. So that we're going to do that. And then we're going to use that authinfo to make a request to GitHub, the GitHub's API. Then we're going to get the list of PRs. Then we're going to hopefully use that list of PRs to populate a chooser. Now, I don't know how far we're going to get tonight on that, but we'll find out. Let me turn on my time here so I can kind of see how we're doing on time. So let's get started. Get that URL response, get that thing going first. I have started this org file in a test repo that we're going to be using to use these PRs, to try to get these PRs to load. And since it's an org file, we can basically use this as a scratch pad to write some Emacs Lisp and execute it and go from there and see how far we're getting on developing this thing. So the first thing we need to do is just make an API response or an API request and get that response and handle it in an Emacs-y way. Now, I do know that Emacs Lisp has a URL package that's built in, and the documentation is aimed at people who are a little more experienced in Emacs Lisp than I am. I'll say it that way. But I did find a couple of resources online to help me parse a little bit of how to do that and how to do it well, and maybe some shortcuts. So let's get started with that. So the first thing I want to do is just use not a random, but a not a GitHub API, but have an API that we can use to kind of test things out with until we get the authinfo stuff going. And I did find just an open JSON response type API that retrieved information on Bitcoin or whatever. So let me just grab the URL for that. So this is the URL that we're going to be using to grab some information. So actually, if I just copy and paste that into here, you can kind of see where we're getting back. It's just a standard JSON response, nothing fancy. But since it's an API request that I can make that doesn't require any authentication, I decided that would be a good one for us to kind of test run stuff with. So that's what we're going to be using. Now, how do we retrieve that in Emacs Lisp? Now, if you have seen some previous videos, you'll know that I'm pretty much a beginner on Emacs Lisp and in Emacs in a lot of ways. So the things that I'm going to be doing may not be the best way, probably not the best way, in fact. But we're going to kind of stumble through it and see if we can just get it working. And then hopefully if you have a better way of doing it, let me know in the comments, and we can go from there. Maybe I'll, make things better in a next video or a future video. But for now, we'll just, hack our way through this thing and see what we can do. Now the URL package does have like a URL retrieve function that we could use, but honestly, I don't know how that works. If we, let's see, let me get the help up for URL retrieve. URL retrieve. So with this, you can see that it takes a URL and a callback, and then it has some optional things. The URL is a string or a parse URL. We would just use the string at this point. But then the callback's the thing that gets me. I don't understand it. It says callback is called when the object has been completely retrieved. By the object, I'm assuming it means the thing that the URL is pointing to, with the current buffer containing the object and any MIME headers associated with it. So callback is called with the current buffer containing the object. It is called as apply callback status CB args, maybe callback args. Status is a plist representing what happened during the request, with most recent events first, or an empty list if no events have occurred. Each pair is one of redirect, error. Don't really need those. Return the buffer URL. Return the buffer URL will load into, or nil if the process has already completed. I don't know if that's telling me to return the buffer, or that the function itself returns the buffer. So, like, honestly, I don't quite get it. I've tried to find some examples. I just couldn't find anything great. But I did find something other than URL retrieve, and that is, let me close this one, URL insert file comments. Insert file contents, not comments, I'm sorry. This has very little documentation, as you can see. It really has none. But when you do use that URL retrieve, it has all the headers at the top, and then the contents of the response at the bottom. And there's no great way that I've found to get to the content, like pass all the headers and get to the content. It seems to be broken up by white space, like a new line. But I read that may not always be the case. And then there's other issues, like there's something called, there's a target or a mark that's like, I can't remember the name of it even. URL HTTP end of headers is a mark that I believe the buffer has when it's returned. But again, that's another one of those, like, it's not really greatly documented. If we do it, let's see, URL, what was it? Header. Let's just do headers. Request extra headers. No. Yeah, see, I don't even know where it is. So let's just use the URL insert file contents, because I have played around with that a little bit. So we'll do that. I do know that we can use this with temp buffer, and that kind of creates a new space, like a new buffer area that we can use during this request. So let's actually look at the documentation for that. With temp buffer, create a temporary buffer and evaluate body there, like prog in. See also with temp file and with output to string. So we'll do this in temp buffer. Let me bring up my little other editor here and turn off fly check mode. Actually, let me turn that off globally. So with temp buffer, and then here we can do the URL insert file contents with the URL as a string. Put the new line there, actually. I think that's all we need to do with that. And then the buffer string will have the contents of the response, I believe. So we can say like what if we just return buffer string? Let's see what that does. I'm actually not quite sure. So I'm going to evaluate that. Okay, cool. So you can see down at the bottom that it just returned the buffer string, which happened to be the response of the API call, this URL call. So that's exactly what we want, which is nice. So honestly, let me do that here. I'm gonna bring up my Scratch to see exactly what I had planned in terms of what to do. So get a URL response. So that's done. We've done that. Actually, let me make that get a URL response. So if we evaluate that, we do get the URL response as the buffer string, and it just right now it just puts it into the messages or the mini buffer and lets us go on our merry way. But we want to do something else with it. So now we need to parse this JSON and pull out something from it. So let's just pick one of these keys. There's like updated. Oh, there's time, updated, and there's a disclaimer. It's kind of long. A chart name, Bitcoin, BPI, USD. So this is like a an object inside of the key. So let's not do that quite yet. Let's just do something on the top level. I think this chart name actually is going to be the best because time is in has an object inside of it, and then disclaimer is kind of long. Chart name's good. Let's do chart name. Okay, so let's try to get chart name. So we have get a URL response. So let's now try to get chart name from the JSON of the response. If I was a smarter man, I would know how to use like store the results of this in some format we can use later. But I am not that man. I could figure it out. I think like I've done it before when I was like studying some Elasticsearch stuff. I took a lot of notes using org mode and started to really kind of get why people like org mode. But obviously the how to evaluate it and store that has not quite stuck. So I'm going to skip that for now, and we'll just kind of copy this into a new area and go from there. So paste that in here. So this is what we have so far. So we have the contents of the response in the buffer. So let's define some things here. So we can say the response is this buffer string here. Okay, yeah, that's good. And then what else do we want? We want to parse that JSON. So let's look in the functions to see if there's anything with JSON. There's that LSP. I don't know what that is. JSON plsp, JSON pretty print, JSON read. Okay, look, JSON parse string. Let's see what that says. Parse the JSON string into a Lisp object. Okay, that sounds promising. This is essentially a reverse operation of JSON serialize, which C. I don't know what that means. Which C. The returned object will be a vector, list, hash table, a list, or plist. Its element will be the JSON null value, the JSON false value, T, numbers, strings, or further vectors, hash tables, a lists, or plists. If there are duplicate keys in an object, all but the last one are ignored. If string doesn't contain a valid JSON object, this function signals an error of type JSON parse error. The arguments args, which we can put as many as we want to, looks like they're optional. The keyword argument object type specifies which Lisp type is used to represent objects. It can be a hash table, a list, or plist. It defaults to hash table. Let's play around with that and see what the different options are. So first, let's just define resp JSON, I guess, as the result of JSON parse string, and we're going to use resp for that. And remember that in eLisp, or maybe in most Lisps, I don't know, this little let star means that we can utilize previously defined variables in the later definitions of variables, which is going to be helpful for us. Like if we just did this, we couldn't use resp here. It'd be like, what? But we use the star, so we can. So let's try that and see what happens. So let me close out that and then close out the let and then close out everything. Okay. Okay, so we got nil. Oh, because we're not returning anything. So after the let closes, or at the end of the let, let's just return resp JSON. See what happens. Okay, cool. So look, now we have hash table size for test equal rehash size 1. I don't know what all that means. rehash threshold. I think that's like maybe data within Emacs itself. Just lost my coaster. Sorry about that. Then we have time, and then that's in its own hash table. Disclaimer. Okay, so that is what a hash table looks like. Other options are A list or P list. So let's try that. So object type. Let's try A list. See what that looks like. Execute that. Oh, they did not like that. Why did it not like that? Parse error. Something was expected. Opening square bracket or an opening curly was expected near the opening. Is this hard when we can't see the response that it got here? So it's interesting that A list doesn't work. Okay, let's try it again. Okay, so the hash table still works. So let's just try to get object type A list. And I think we want that with the... Oh, there we go. Maybe we just had a weird API issue. Okay, so here we have... This is the parentheses version. So it's got time and then updated, then the dot, and then the value. I'm not very good at using this type of format yet. I'm not exactly sure how to dive into that, to be completely honest with you. I'm sure we could figure it out, but let's see what the other version is. So the other version is plist. So let's execute that. Okay, so this one looks more kind of like, I don't know, Ruby's hashes or Elixir's symbols, and I'm kind of used to those. So yeah, here's our disclaimer. Here's our chart name. That's kind of what we want. We want chart name. Okay, so let's use plist for this. Okay, so we're storing that into RESP.json, and I think there's like a plist get. Plist get. Let's see what that says. Extract a value from a property list. Seems pretty straightforward. Plist is a property list, which is a list in the form of prop value 1, prop 2, value 2. Okay, this function returns the value corresponding to the given prop, or nil if prop is not one of the properties on the list. The comparison with prop is done using EQ. This function never signals an error. Okay, so let's try it. So we're going to say that the chart name, let's just do this. Chart name is plist get, and then the next thing is the plist, which is our RESP.json. Should we call that RESP.json plist instead, just to be explicit? Let's try that. And then the prop we want, which is, I think we can pass in chart name like this. Let's try that. Okay, so, and then instead of RESP.json, we want to return chart name. Execute it. Bitcoin. Yes. Yes, you guys can see that. Awesome. So we are retrieving Bitcoin as a chart name. That's great. So let's install this. Let me close up these parentheses up here. And that's how we get chart name. We're going a little quicker than I expected. The next thing we want to do is dive into authinfo, and this is going to be the potentially tricky part because my secret may be exposed, and I would rather it not. But we'll go for it. We have, if you're not familiar with authinfo, it's a way to store secrets within Emacs, and it has different formats it can follow. Actually, let's close this. And is there like is it in the manual? Let's see, which one's manual? There's info. manual entry. Get a Unix man page. No. Info Emacs manual. Display the Emacs manual in info mode. Sure, let's try it. What do we do? Authinfo. Authentication. Keeping persistent authentication information. Okay, so cool. Let's look in here. Some Emacs packages which connect to other services require authentication. That's us. Because it might be annoying to provide the same username and password again and again, Emacs offers to keep this information persistent via the auth source library. By default, the authentication information is taken from the file .authinfo in your home path, or homepath.info.gpg, or homepath.netrc. These files have a syntax similar to netrc files as known from the FTP program, like this. So there's machine, which I believe corresponds... No, I think these are like... Machine is set. Like you type in machine, and then my machine is the thing you change. So I think my machine would be the like the host name or the thing you're trying to store information about. In this case, it's going to be... In our case, it's going to be api.github.com, I think. Although I don't know if it actually matters. I think the library, whatever library is using or is requesting the information, as long as it knows what it's stored under, then it can use that. Login, then you have your login name, username, and then your password, and then your port. I don't think you have to have your port. Okay, so let me show you. This is the part where it could be a little dangerous, but I'm going to show you my authinfo file. And I have mine, it is encrypted, but my Emacs is set up to automatically decrypt it when I open it and then automatically re-encrypt it when I save it, which is pretty cool. So let me go back to my, oh no, I got to get out of, there we go. Here we go, authinfo. Now here is my authinfo. So you can see my password is obfuscated because I have this authinfo mode on, which hides that, which is nice. So we have machine, and the machine is going to be api.github.com. And then my login is my username on GitHub. And my password is 4 stars. That's it. It's just 4 stars. People said I should probably change it, but I think that's secure enough. No, I'm just kidding. So that's what it looks like. You would enter this manually. You can do it manually. I think there's some packages that allow you to enter it programmatically. We're just going to take this information and use it to try to access GitHub's API. So let's go back here. And so the next step is going to be to, what did we say it was going to be? Let's go back to scratch. Use authinfo. All right, so get the information. So get info from authinfo. And we'll go into a little bit about how that works. So how do we do that? Let's just start defining some variables here in a let. And we have our credentials. Let's just call them creds. Now it has, there's this function called auth source, what is it? Auth source search. Yes, auth source search that I found. And you can kind of pass it a spec. It says search or modify authentication backends according to spec. This function parses auth sources for matches of the spec plist. It can optionally create or update an authentication token if requested. So this is one of those ways that a package can programmatically enter your information into your auth sources file. We're not going to do that, but we're just going to read it. A token is just a standard Emacs property list with a secret property that can be a function. All the other properties will always hold scalar values. Typically, the secret property, if present, contains a password. Yes. Okay. So a string value is always matched literally. A symbol is matched as its string value literally. All the spec values can be single values or lists thereof. Create T means to create a token if possible. So it has an example here. So it says let auth source creation defaults. I guess that's the variable that they're setting. And then it says auth source search, which is what we're going to be using. Host mine, type netrc max 1. P, I don't know what that means. P's and Q's. Oh, which says, here's the Q stuff. We prompt for the user with default user. Oh, this is for possible creation. The P's and the Q's, I'm not sure what they're doing with those, but we won't worry about it. Let's just try it out. So we have creds here. Let me go back over here and see the function auth source search. And our spec is going to be the host name, which is going to be api.github.com. And let's see what comes. Oh, we need to define what we want to call this. Let's say creds. So let's see what comes back from this. Yes, close that there. Creds. No, we don't need to put those in parentheses. So what comes back from creds? There we go. So you can see down here we've got, host api.github.com user geolessel and then the secret, which is this crazy looking thing. Now that is actually a function that you can call to get the actual password, which is kind of cool. So it just passes around this compiled function that you have to call to get that password, which I find interesting. So that being known, we can pull out things from it. So we can say like username from that was let's use that plist get again because it was a plist, except the plist, how did it return? Okay, let's call that again. Okay, so it's inside its own parentheses. So it has two parentheses, another parentheses, and then an inner parentheses, and that's the one that contains the information. So how do we get the first value of a parentheses? Plist get. I think we can do something. It could be like car or CDR. Let's look. So car. Can it just car? Car. Safe car. Okay, car. Let's see what that says. Car list. Return the car of list. If arg is nil, return nil. Error if arg is not nil and not a console. So what is a car? Let's try it. Let's just go out of this and just try something crazy down here. Let's just close up whatever it's complaining about. Okay. So let's say car and then just pass it a list. 1, 2, 3. Let's see what that does. Okay, so it returns 1. So like what is, okay, is it CDR? That is the other one. CDR. CDR. It was like an exclamation CDR. Okay, CDR. Return the CDR of list. Okay. Let's CDR. Let's try that. What's that going to return? Okay, 2, 3. So in Elixir terms, which I'm more familiar with, it would be like the head and the tail equals 1, 2, 3. So then the head would be 1 and the tail would be the list 2, 3. So like head would equal like 1 and then tail would be 2, 3, which means we can kind of assume that head is like car and tail is like CDR. I have no idea why they're called that. It's kind of weird, but don't care about that right now. Let's delete all that. So we want car of creds, which is what we just defined, and we want the user plist value or value from that plist, and we'll call that into username. Let's see what we get back for username. Yep, that closes up right. All right, cool. Username is geolessel. That is me. And then we can get the secret the same way. We can say plist get car creds. Password actually is what it called it, but I'm going to call it secret here. No, you know what? I think it does call it secret. If we look back in the manual, what was it? Auth source get search. Auth source search. There we go. The secret property. Okay. Yeah, it looks like it's name secret. So we'll do secret. That's fine. I'm not going to post out my secret here. Let's call it again. We're still getting our username. In fact, actually, let me do the secret. Well, okay, I was thinking about pausing the video and making a little edit here, but I'm just going to cover up the secret. I think in order to get the secret, we have to call it. So if we just say secret, if you look down in the line here, you'll see it's a compiled function, and I know you can't see it past the bytecode stuff, but if we call it, which I think we can do with func call, then it actually comes up with the string with the actual secret in it. So that's how we can get the string of the secret, and that's kind of what we want to do. All right, so what was the goal of this particular section? We wanted to, let me actually install this. I keep calling install. I don't know if the right word for it, but let's not return that. Let's just return username for now. Username. Okay. So we have those being successfully retrieved. So that, let's just say use authinfo is done. Next, we want to make a request to GitHub with the authentication. Okay. Make GitHub request. That's Emacs Lisp. Okay, so in here, what are we going to do? We obviously need to use the two things that we've done so far. Get the URL response and use authinfo information. So let's go look at the documentation for GitHub. And you can see, let's see, overview, authentication methods. We're going to be using this basic authentication with OAuth, with an OAuth token. And it's going to be a personal access token. And it basically takes the username and the token, puts a colon in between them, and uses a header to pass that authentication on. And I believe the header name is authorization. There's some that are authentication, I think, that some use, but we're using authorization with the result of putting together the username and the token or the secret, and then putting that colon in between. We also have to take the base 64 value, I think it is. We have to encode it, base 64 value. So let's do all those things. What first? Okay, so the first thing we want to do is pull out the username and password. Yeah, let's generate this base 64 encoded string. All right, so let me just copy paste this because we need this. All right, so we have our username and secret. Perfect. We're going to use those. So let's put another line in here. So the next thing we want is, let's call it encoded auth string. I don't know. Let's do encoded auth string. How about it? And it will be, we'll have to concatenate the user name and the secret, and then base 64 encode it. So we gotta think outside in here. So first we want to do like a, what was that, base? Yeah, perfect. Base 64 encode string. So it's expecting a string. There was some documentation that came up here. Come back, documentation. How did that do that? Okay, there we go. Built-in function. It takes the string and then an optional no line break. No line break means do not break long lines into shorter lines. That's true. We don't want long lines and shorter lines. Okay. So the string we need to pass it is a concatenation of the username and a colon and the secret, I believe. So let's look at the encoded auth string. And again, you probably won't see this full thing. Oh, I want either. Wrong argument type character P for what? Oh, because the secret is actually, you have to, remember, we have to call it. So it's going to be func call secrets. Let's try that. Perfect. Okay, so in my message line, you can kind of see parts of it, I imagine, is the secret, or the auth string that it generated, which is perfect. So we have the auth string. Now we need to use that with URL to send a request to GitHub. And let's just say, okay, well, first we need to set the header. And I do know that there's this, there it is, URL request extra headers. It's a variable. Its value is nil right now. It's a list of extra headers to send with the next request. It should be an ASOC list of headers and contents. So we need to set this. Now, one thing I figured out in fooling around a little bit with some of this stuff is, like, typically I would think that it would be something like this, authorization, and then an ASOC list, I believe, is this, and then we needed that encoded auth string. Yeah, so if we tried that, like I think this will even just fail. Like we're doing anything different. So no, it didn't fail. Okay, well, let's make a URL request then. So let's take out this URL encoded auth string, and let's do something with the variables we have defined for ourselves here. So again, we want to kind of go back into this with temp buffer. And instead of api.coindesk, we're going to say api.github.com. And I think they have, like in here, they just go to /user. So let's try that. /user. So insert file contents of the request when you retrieved this URL. And that's going to be in the buffer string. So that should be the thing that returns. So let's do that. Okay, so here's where I got confused one time, very recently, trying to figure this out. We have this wrong type argument, sequence P encoded auth string. So I think this is because of the list we're trying to provide to URL request extra headers. And I could have sworn it was going to be this little apostrophe, but instead I found out it's actually this backtick or grave mark, or it has different names. But if you, well, let's keep it like that and see what happens. So now we execute it. It still blows up because we have one other issue that is we need to apparently that was weird. Pause for a minute. Like, comma this, I think, and do that. Let's try that. No. So, oh, you know what we need to do anyway? We need to concatenate something else, because we have to put basic in here and then the encoded auth string. All right, what's that going to do? Is that the right number of parentheses? It is. Okay, see, now we get the request. So honestly, I got to be completely honest with you here. I don't know exactly what this backtick or the comma does here. So we can look, like if I can search in apropos for the comma and see what it says. So let's look at the properties here. Properties, function, okay, symbol commas, plist is function documentation. C equals also p case for the usage of comma. Okay, so let's look at p case. P case, is that a column? Yeah, there we go. P case here. Okay. Okay. Evaluate expression to get expression value. Try passing control to one of cases. cases is a list of elements of the form pattern code. Okay, that's REST. Like, we didn't even use that. So each pattern, it goes in all these patterns. See, like, I don't understand. I mean, it evaluates the expression to get the value. That's what I understand. And we needed to evaluate the concatenation to get the value. But what I don't understand is why, if we just do this, why this doesn't work. Because I thought that you call functions with the beginning, the first argument of a list here. So, like, if we call this, we still get this argument that it's just using concat. And then maybe because of the whole, like, head tail thing, like, it's still, it just thinks it's a linked list or part of another list, something like that. But to be completely honest with you, I'm not going to spend too much time on trying to figure that out in this particular episode. I'm just going to say, sweet, we got the URL request working, and go from there. So, like, right now it's contacting it. It did not work that time. Why did it not work that time? We have the comma back. Let's try it again. There we go. I must have pressed it before. No, I don't know what happened. But we have it now. We have a response from GitHub. That's what we wanted. Make the GitHub request, and perfect. That's what we needed. So let me make that a little bit better. This one too. Okay, so we can call that done. Let me just save our progress here. So this is done. Done. Git list of PRs. Now, I have not done any sort of experimentation with this yet. So we're going to be looking at the GitHub API docs together. REST API polls. I did have this pulled up, but I haven't done any reading of it. So this allows you to list, edit, view, create, and even merge pull requests. We just want to view. Comments on pull requests can be managed via the issue comments API. Every pull request is an issue. It's fine. Custom media types pull requests. We just want the JSON. I don't know. We'll see what comes back. Pull requests have these possible link relations. I don't. Okay, the HTML location of the pull request. We're going to need that. So let's remember that. Okay, so list pull requests. Perfect. Draft pull requests are available in public repositories. Oh, draft pull requests. We don't need draft pull requests. Okay, I don't think that's going to be good. Okay, so owners, then the repos, owner, repo pulls. Now, I do have some custom functions that I've written in the past to deal with getting things like the repo name. So that's going to come in real handy here. So let's try that. First, let's hard code it. Let's just hard code it. So git list of PRs. Git list of PRs from GitHub. And let's go in here and do it. So we're going to use what we've already been using. So just copy and paste this, what we've got so far. And instead of buffer string, we're going to keep go. No, we're actually going to get repos /glsl/ I named this particular repo. What did I name this? Forgot what I named this. Well, you know what? Let's run my thing. So if I say git organ repo name. Okay, Emacs GitHub. Perfect. Emacs GitHub. And then / it was pulls, I believe. Yeah, pulls. So what is that? Let's just run that and see what comes up. Okay, so I've opened two pull requests as tests. So we have, I think this is too long to fit in the mini buffer here. So let's go to messages. Let's go over and do it over here. Messages. Okay, yeah. Here is what we received back. I'm going to copy that, get out of messages, and let's open up a new buffer, new, paste that in, and say this is JSON mode. What's it gonna do? It's doing something. It's chewing on something. There we go. And can we pretty print this in JSON mode? JSON pretty print selected region. So we need to select the region. And I'll try that. JSON pretty print. Oh, we have pretty print buffer. That would be nice. Okay, let's do that. Pretty print buffer. Do it. Do it. Oh, I don't think it likes the JSON, maybe. Does it think this is pretty printed? Oh, it's because of these escapes and stuff, maybe? Or maybe because it's surrounded in quotes. No, because then the escapes wouldn't make any sense. All I know is it's super slow to edit this buffer. Okay, what happens if we try to pre-print here? It's not going to work, but it also doesn't give any errors. I wish it would give some errors. Nothing. All right. Oh, there we go. Bad string format doesn't start with a quote. Oh. Well, let's add those quotes back. Oh gosh, it's so slow. Why is it so slow? It's not that much of a JSON payload. All right, back to here. We parsed the JSON here. Let's just try to do that now as well. So we got the file content. So now we need to do another let. And let's copy and paste this. Actually, let's put that up there. Okay, so let's copy and paste this. So we're letting the response be the buffer string, then the response JSON plist be the JSON parse string of the response as a plist, and then we're not going to get the chart name. But let's print out the rest JSON plist. One more. There we go. Let's try that. Nope. Void function resp JSON plist. Yes, because no. Oh, it's not a function. It's a variable. Try that. Okay. This we could potentially use here. Oh, we've got an array. And does each... Yeah, it looks like this array has two values, each with its own, that's not what I wanted, each with its own, I guess we should look at the example, right? Yeah, so it's got an array. Each PR has its own object in the array. It's got a lot of information. Jeez Louise. Okay. Man, we don't need all that. We just need links, honestly. All I want to know, I want the title, and I want the link. So the title, maybe, and the URL, maybe the number. I don't know. Right now, let's get the title. Okay, so we have an array in eLisp. Have I ever done an array in eLisp? Oh, geez. All right, let's go to documentation. Apropos, what is this? Nothing. Shoot. Nothing comes up. Do we have array? There's array mode. That can't be it. Darn. Well, all right, let's look at this documentation. eLisp, I believe. Okay, so if I, array P, functions that operate on arrays. Okay, so this operates on an array apparently. This function returns T if object is an array. Let's see if it is. Why not? So go back in here to get the thing. So is array, array p. I think the p stands for predicate, so it's like array. It could be kind of like that, like a question mark. Resp JSON plist, and we'll return. Let's message out that is array. Does that close everything? Yeah. Let's try that. T. It is an array. Okay. So arrays. Tell me about arrays. Previous arrays. Arrays. An array object has slots that hold a number of other Lisp objects called the elements of the array. Any element of an array may be accessed in constant time. Sounds like an array. In contrast, the time to access an element of a list is proportional to the position of that element in the list. Interesting. Emacs defines 4 types of array, all one-dimensional: strings, vectors, bool vectors, and car tables. Vectors and car tables can hold elements of any type, but strings can only hold characters, and bool vectors can only hold t and nil. All 4 kinds of arrays share these characteristics. The first element is index 0. Okay, 0 index. The length of the array is fixed once you create it. For purposes of evaluation, the array is a constant. It evaluates to itself. The elements of an array may be referenced or changed with the functions aref and aset. Referenced. Okay, so aref. This function returns the indexed element of the array, or record R. The first element is an index 0. So let's try that. So we don't want is array anymore. We'll say first PR. Let's just get the first one, see if we can do that. And that's going to be aref on the array, which is our JSON plist. And let's print out the first PR. Execute that. Nope. Wrong number of arguments, aref 1. Index. Right, we've got the index, and that's going to be 0. 0 indexed, so the first one. Yes, okay, so the second PR comes up first, but that's okay. I don't care about the ordering at this point. And next we can get out the name of it, because we know how to get stuff from a plist now. So first PR name, let's just be explicit here and just operate these one at a time. We need plist get name, I think is what it was. First PR name. Will this work? Dang. Oh, right. Oh, wait. What was the error? Wrong number of arguments, plist get 1. Oh, we haven't told it what to get from. We need to get it from first PR, that array. Or that object, or that plist rather. Okay, and it's nil. Title. It's not name, it's title. Title. Step 1. That is the PR name. Sweet. All right. Let's also get first PR URL. Plist get first PR. And it's going to be, just URL. Okay, URL. This would be cool if it works. URL. Yes. Yeah. Sweet. All right, I'm glad you were still with me here. We have the name, we have the URL, and let's just, for now, create something that uses both of those things, like just a string. So let's say it's going to be temporary, so let's just say that's str. So it's going to be, we're going to concatenate, actually let's do format, %s, so that's going to be the title is at %s, that's the URL. So let's put some quotes around that. And then this first, not a comma. So the first one's going to be first PR name, and the second is going to be first PR URL. So let's see what that does. Yeah, step 1 is at and the URL. Nice. That's what we wanted. So now I need to do that for each element in the array. How do we do that? A set fill array. Nope. I think we can do stuff on like lists with like a do list. Okay, do list. This construct executes body once for each element of list, binding the variable var locally to hold the current element. Then it shows an example of how to reverse something. So let's just try do list. See if that's what we actually want. So we'll see if it works in an array rather. Okay, so do list, and the array is going to be 1, 2, 3, I guess. The next thing, so the var, so do list ELT, that's the element, I guess. Then the list itself and the value. Wait, what? This construct executes body, which is like the function, I guess. Once for each element of list. That's the second argument. Binding the variable var locally to hold the current element. Okay. So do list. Here's our so number, and then our list is going to be 1, 2, 3. Then it returns the value of evaluating result, or nil if result is omitted. I don't think we need the result. Because we're just going to message them out, I guess. All right, so we have the var, we have the list. Now we need the body. And that's going to be message format. The number is S. Number. That might be I. Let's try it. Nope. Wrong type. Argument list P. Yeah, so it won't work on arrays. How do we do we know the size of an array? Because they can't change. The size can't change, rather. Okay, what happens if we try to reference one that isn't set? Doesn't. Oh, see also the function ELT and sequence functions. Let's try that. This section describes functions that accept any kind of sequence. Cool. So we have length, you have ELT. This function returns the element of sequence index by index. Perfect. The legitimate values of index are integers ranging from 0 up to 1 less than the length of the sequence. If sequence is a list, out of range values behave as for nth. For definition of nth, see definition of nth. Otherwise, out of range values trigger an args out of range error. Okay. There's copy sequence, reverse sequence, in reverse, sort, seek elt. This function returns the element of sequence at specified index. Oh, so basically it's kind of like you give it the value and it tells you the index, I guess. No, I don't know. Not what we want though. Seek length, seek p, predicate, seek drop, take take while, drop while, do. This function applies function to each element of sequence in turn and returns sequence. That might be what we want. There's also mapping functions, filtering. Oh, this is cool. Removing, reduce. Okay. Sum, find, every. Predicate sequence. This function returns non-null for applying predicate. Okay, now count, sort by contains, set equal, set position, unique, subseq, concatenate, mapcat, dang, there's a lot of these. Intersection, difference, group by, into, min, max, do, seek. This macro is like do list, except that sequence can be a list, vector, or string. So what's the difference between this and the other one we just saw? Okay, so let's remember seek, do, seek. It was seek, do. This function applies function to each element of sequence in term and returns sequence. All right. This macro, it's a macro, is like do list, except that sequence can be a list, vector, or string. It's primarily for side effects. So let's just do that one. We just want the side effects for now. Okay, so do, not do list, but it said like it, so maybe we can just drop it in. Do, seek, do, seek. Let's try it. Boom. Okay, return the sequence. Yeah, return the sequence. Now, let's look at the messages buffer. Number is 1, the number is 2, the number is 3. There we go. Cool. So seek, do, seek could be what we want, but we don't want its side effect. Shoot, we want like we want its own. We want a list or an array or some sort of sequence. We want to map it. Okay, get out of here. We want to map it. So seek. We had the map. Seek map. This function returns the result of applying function to each element of sequence. The return value is a list. Okay. We can deal with that. For now, let's just do the names. Oh, let's concatenate the name and then put the number at the end, or maybe the number at the front and then the name. Let's do the number at the front and then the name. Okay, so we want to break in here because this is all like just the first one. We want to do this every one. So we want to do seek map, and it takes the function and then the sequence. The function. Oh shoot, I don't know what the hash in front of the name means. This function returns the result of applying function to each element of sequence. The return value is a list. So we may be able to inline that with like a lambda. I don't know. Let's try it. Lambda. And it's going to be a PR object or plist. Okay. And for each of those, we want to concatenate the number first. Oh, let's just do format. Let's do format. Format percent I number, the hash percent I. Let's not do any sort of like a dash or something like that. We could do a dash, but let's not do a dash for now. And then the name. So the first part of that is going to be plist get from the PR the ID. I think the ID is going to line up. ID, no, it's not. So pulls number and ID are different. Number, okay, number. And then plist get from the PR the title. And then, so that's the function. Then we need to do pass in the sequence, which is the resp JSON plist. We should rename that because we know it's the return from the PR from GitHub, we should probably do something around that. Okay. All right, so that's our seek map. Oh, but we haven't assigned this the actual value. Let's just call it PRs, and then we need to actually do that. And then let's just format those correctly. I don't know if that's going to work, but let's try it. So we don't need these anymore. I'm just going to comment these out. We do still need that. That still closes up things correctly. So instead of first PR str, let's return PRs and see what happens. Darn. Void function, resp JSON plist. Oh, right, it's not a function. I keep doing that. All right, try it again. Come on. Oh, wow, it worked. Look at that. Number 2, step 1. Number 1 is step 2. Well, that was I did that backwards. That's real confusing. Okay, well, it did what it's supposed to do. Perfect. So now we can get a list of the PRs from GitHub. And this does that correctly, which is pretty cool. I think everything is formatted. Let's just format buffer. Okay, cool. Okay, let's install that. Cool. So now we've gotten the list of PRs from GitHub. Boom. Oh no. You know what we didn't do though? We still have hard-coded the PR location or the repo. Instead, we want to, let's say format. Let's bring this back in the editor. Format. Let's put an enter in here. Format this, but instead of repos glsl emacs github, we want to put the %s in there. We want to keep the polls. And then here, for the %s, we want to call geogit organ repo name. Organ repo name. Should we try it again? Is that everything? Nope. I forgot to close off one parenthesis. Yes. Okay, so that still works. Sweet. Is this gonna look weird? No, that's not what I wanted. Let's do it like this. Yeah, that's a little more clear. Still works. Okay. All right, let's install that. So now this could work in any repo that you're working on in Emacs. That's cool. So let's define a function here. Maybe we should have been defining these functions all along, or defining these as functions all along. We also need some renaming. Let's rename some variables first, because some of these are going to drive me crazy. So encoded auth string, that's a long name. Let's just call it auth string. So click through that auth string, and then we have resp JSON plist. So let's just say resp plist PRs plist. Let's do that. So that's going to be PRs. Nope. Whoop. PRs plist. I think that's good enough. We don't have to store resp anymore. So we can just say, instead of resp, we can just say buffer string. And there. The rest we should just keep, I guess, for clarity. Still works. Okay, cool. All right. So let's define it as a function. define the function geo GitHub list PRs for repo. Eventually we can like allow them like maybe like pass in a repo. But for now, let's not. So let's just say we can do it interactive for now, just so we can test it out still. And then we need the documentation string. I think what's next? List open PRs. Oh, we need to filter them to only open ones. That's my main goal. List open PRs for the current repo in GitHub. For the current repo. And then, whoop. Let's just tap all that over. And back to the documentation for the API. Can we filter this? Create get a pull request, list commits on a pull request. This is going to be so cool. Check if a pull request has been merged. Reviews, review requests. Parameters. Okay. Whoa. Here we go. Owner, repo. Yeah, we have those in the URL. State, open. Okay, let's try that. I think the best way to do this, unfortunately, for my sanity and the way I like the code to look, I think the right way to do this is to do like URL. I think there's something in here for that, like a variable you set. Request data. Any data to send with the next request. I don't know if that goes in the like query params though. Handler proxy request method. Oh geez. No. Request non-interactive. No. Parse args syntax. Whoa, that's not what I wanted. Oh man. Basic auth. Oh. Do we have? Maybe we don't have to set the headers. We may not have to set the headers explicitly. Like there may be something built in, which would be cool. URL auth. No. Okay, let's look for variables. URL auth. No, it wasn't auth. It was like the query params. Query allowed cars param. No. What was it? Request data. Let's see what that is. Any data to send with the next request. That just does not sound right. Oh. No. Well, okay, hold on. There may be let's see, there may be a example, like a Git example in the URL documentation in this info manual thing. Retrieving URLs. Okay. Yeah, you retrieve. That's the stuff we looked at earlier that I don't quite understand with the callback. URL queue retrieve. Timeouts. Darn. Let's see. Go K. URI parsing. Generic parse URL. You create URL. Parsed URIs. The username. Password. Host port file name. Target fullness. Slots. No. Not looking right. Next, GJ. Yeah, encoding. Generic parse URL parser does not obey encode URL string. Hexify string, unhex string. No, none of that. None of that's sounding right. All right, let's just, for now, because I'm getting tired, let's try putting it in the URL itself. What was it? State equals open, I believe it was. State open, yeah. Let's run it. See if we make sure we still get this number 1, number 2. Nope, we don't. Invalid function. What? Our auth source search is now an invalid function? Did we break something else? Oh. Duh. We left that up there. Okay. Okay, we still get the stuff. That's good enough for me for now. I'm going to save this. I'm going to put down here in the to-dos. Let's say better handle query params in GitHub URL. And allow, are we going to allow this to accept a repo, or is just the current repo? List PRs for, let's just say for current repo. All right, so we have a function, list PRs. Actually, we haven't checked this a function yet. So let's actually define the function and call it geo GitHub list PRs for current repo. It's taking a long time. Come on, GitHub. Don't fail me now. Oh. Since it's a function, what it returns is there's nothing being done with what it's returning. So let's go back in here. Let's message PRs. And then return PRs. Sure. Why not? So let's redefine that. And then let's call it. So interactively, oh, not messages, message. So you redefine it again, call it again. Wrong argument type string. Okay, so it expects the string and message, but we're getting PRs. But that's like just the the error is good enough for me for now, because I know that it's still working as the function. Is there a way to like convert a list to a string like automatically? Is that something built in? Message. I just want message. How do I do that? Okay. Nope. Help. Function or callable message. There. All right, format string args. Display message at the bottom of the screen. The first argument is a format control string. And the rest are data. Okay, %, grave accent, apostrophe are special in the format. Format message for details. Let's look in there. That's like format. Okay, let's go to format. As a string argument actually prints any object. Let's try it. So back out of that, back out of that. So we want to print any object as a string. Is that going to work? Redefine it. Let's call it interactively. Yeah, that worked. Cool. Okay. So why is that still selected? Be unselected. It's weird looking. Don't be weird looking. What in the world? Oh, I was like not in the editing buffer. That was weird. Oh, and then I entered a J in all of this. Okay. It's getting pretty late. Let's call this an end thing. So if we go back to our initial scratch buffer, our initial to do, scratch. Yeah, we got done the list of PRs. Now we need to use list of PRs to populate the chooser. I'm not going to do that tonight. We've gotten plenty far on this, and I'm very happy with how far we got, actually. I was kind of expecting to get through half that, but the first few kind of flew by, so that's pretty cool. Let's call it done. If you have any recommendations on how I can do some of these things better, let me bring this back up. So this is what we ended up with, our function definition. That's what we ended up with. If you can think of a way to do that better, which there's gotta be ways, let me know. Also, if you have a good way to explain to me what the backtick and the comma do in here, I would really appreciate that. I haven't grokked that quite yet as part of the Lisp learning process. I just don't know what those are. And I was happy we were able to pass in like a lambda here, so we have to name the function. And I'm not sure which completion like engine or whatever we're going to be using, or how to. I don't know how to pass in to a chooser the list and then do something with it. Like I don't even know. Like I think if you have a list provided and you select that particular value, then I think all you get back is the value. But what I want is to display the title and the number, kind of like we constructed. But then when you press enter, I want it to use the URL that we haven't even pulled out yet, but that's gonna be easy. I want to go to the URL. I don't know how to do that. So that's gonna be maybe the next video. Yeah, again, thanks for watching. If you have any suggestions, please let me know. There's ways to do this better. Let's do it better. And I'll even post this up to the repo. And you guys can look at it in detail. And I also... No, that's good. Let's do that. I'll put it up on the repo, make it public. Take a look at it. Use it. Try to figure out how to make it better. Post in a comment or in a PR ways you think we can make it better. And let's do that. So thanks for joining me. I really appreciate it. Like, subscribe, do those YouTube-y things. And I'll see you next time. Again, thanks for showing up.